Hi friends, welcome to my channel. Today I am going to explain the concept of a ray diagram. Okay, that is from the lesson Light Reflection and Refraction. Okay, from the science physics part that is light reflection and refraction lesson for the class 10th ray diagram. See, before going to draw that ray diagram, we should know about the properties, means nature of the mirror. See, generally we can see our image through plane mirror, and again two more mirrors are there. Those are concave and convex mirror. See, if I draw like this curved surfaces, two curved surfaces. This is a reflecting surface. This side is a reflecting surface and another surface that is coated. Okay. Here also, if I consider this as a reflecting surface and another one is coated, this is a convex and this is concave. Which mirror is curved inward and which mirror is curved outward? Those are concave and convex mirrors. Now, we should draw the ray diagram for that one. Before going to draw the ray diagram, we should know the nature of light when it passes through the concave and convex mirror. So, first now I am going to consider concave. First is a concave. See, the center of a curved surface, that is called as a P, pole of the mirror, pole of the concave mirror. And if I draw one line perpendicular to that point P, okay, that is called parallel axis, and we can see two more points. Those are C and F. C is center of curvature. That means center of curvature of spherical mirror. Every concave and convex mirrors are the part of a spherical mirror. So each spherical mirror have the center that is known as the center of curvature. And what is F? F is the focus of light. See, when sunlight, when you use these mirrors for the sunlight, those lights, ray of lights reflect and converge at one point. Okay, that is called the focus. When the reflected rays are converged at one point, that is called the focus. Here also this is considered focus. And if I draw one parallel line, that is a ray of light. If a ray of light pass parallel, if a ray of light pass parallel to the parallel axis, how it will be reflect? Is a question. So it will reflect through the point F. This is the first nature. Okay, this is the first nature of light. Parallel line, when it pass parallel, when it incident parallel, it will reflect at F. First nature. Next, second one. Second one is going to pass through the point F. Okay, it is going to incident through the point F and reflecting parallel. Okay, it is going to reflect parallel to the parallel axis. This nature is just reverse of this one. When incident parallel, it will reflect through the point here. When a ray of light, when it is incident to the point F, it will reflect parallel, just reverse of that one. Very easy to remember. Next, if I consider one more concave mirror, say one side is coated while we drawing also, we have to indicate that one. Another end is coated. So here, this is a P, F, C. Two nature over. Incidenting, reflecting, incidenting, reflecting. Another is a ray of light that will be passed through the point C. That will pass through the point C. When the ray incident through the point C. This is very easy. It will reflect back in the same direction. Okay, this is the second diagram. This is the first one. This is the second one. And this is the third one. In this third diagram, what happened? We are going to consider the ray that is passing through the point C. When it passes through C, it will reflect back in the same direction. Very easy to remember. Next one, I am going to consider concave mirror. Point P, here F and C. Now, the ray of light is incidenting to the point P. Okay. When a ray of light incident at a point P, it will reflect back in this direction because it is going to follow the law of reflection. A law of reflection says if any ray incident to that reflecting surface, the incident angle is equal to the angle of reflection. Incident angle is equal to the angle of reflection. So, it follows when a ray of light passes through the point P. That time, when it incident, with the same angle, it will reflect back. This is the most important concept to draw the ray diagram. First, we should know when any ray pass parallel to the parallel axis, it will pass through F. If it is incident to the point F, it will reflect back parallelly. If it is passed through C, it will comes back in the same path. When it incident at P, with the same angle, it reflect back in the another plane down. Okay, this is the most important one concept. Now, after that one, we can place the object. When you place the object beyond C and also at the infinite distance. Okay, infinite distance. When we place the object from infinite distance at infinity, I am going to consider two rays. I am going to consider two parallel rays are incidenting, and we know the nature. Those parallel lines reflect at F. Reflect at F and image will be formed here. Small point size image we can see. Point size image at F. Okay, so this is at infinity. When you place the object at infinity, object size is point size. Object not image size is point size. We will get the image here. Just if I consider one more concave mirror, parallel line, F and here C. Now I am going to place the object at the C. Okay, here at infinity distance, that's why we can't draw the object. Here I am going to consider the object. This is the top of that object, this is the bottom of the object, this object. Okay, now in this I am going to consider two rays. Okay, one is a parallel ray and another one ray. It will pass through F. Okay. If I place the object at C, one ray is passing parallel to the parallel axis and another one will be pass through the point F. Now we know the condition parallel definitely pass through F and the ray of light when it incident through the point F, it will definitely pass a parallel. So these two lines are going to meet at one point. Okay, one is a parallel reflect at through the point F, and one more is pass through F. It will reflect back parallel. So you will get image here. Okay, inverted image. Okay, inverted image we will get. This is the nature of that light. So image formation, that is down of that object, means inverted. Okay, real and inverted image we can see when you place the object at C. Now, if I place the object beyond C, if I place the object beyond C, what happened? One more, parallel line. We know that one always we have to consider one line parallel and another one at C. Okay, it will pass through at C. Now, when you draw like this, parallel, it will pass through F. You know the condition. When you draw these two lines, always while you drawing the ray diagram for image formation using the object by placing different position, we should know that one where the lines, where the ray of lights are going to incident. See, first one parallel. First one is two parallel lines. Second one is parallel and pass through point F when you place the object at C. And here you are going to place the object beyond C. When you place the object beyond C, one is parallel and another line is passing through the point C. If you know those, then remaining is easy. Because if you know the condition, will be easy. It is pass through C, pass through F, and any line when it incident through the point C, it will reflect back in the same direction. So where will be the image form? Here. Those two lines, where those two lines are converge here. Where those two lines are meet, no, those 2 points are helpful to give you the image here, inverted image. Okay, those 2 points are going to meet at one point. The lines are going to meet at one point. So inverted image we are going to get. Next. Okay, now at the C over, beyond C over, now I am going to place the object between C and F. C and F. One is, we know that one parallel line, and another one is above the parallel. This is a line for that parallel line above that one. I am going to consider these two rays. And we know the condition, parallel line will pass through the point F. Okay, and while you drawing now, this line I'm going to draw here. Okay, incidenting 1, 2, reflecting parallel. Know the condition, it will pass through. And here, when this line incident, it looks like it is coming from C. Okay, it looks like it is coming from C. So if I draw here, you just see that one C. Just see. Okay, if you extend those two lines are meet at one point. Okay. And those two lines are meet at this point. So draw the line here. This is a image. Okay, one is a parallel and another one is above that parallel line. If you consider those two, how those two lines are reflecting? One is parallel, we know the condition, it will pass through F, and one more line that looks like it is coming from C, and we know the nature when any line that is incidenting from C, it will reflect back in the same direction. So this line won't reflect in any other direction, it will reflect in the same direction. So when you extend those two lines are going to meet at one point. So from that point to draw the line, that is inverted image of this object. So image will be enlarged. Image is larger than the object size. Here the image size is smaller than the object size. Okay. Now I am going to consider one more two ray diagrams. For that I am going to rub this. Now, beyond placing the object beyond C, at C, between C and F over, now I am going to place the object at F. Here also condition, one is parallel to that parallel axis and one more is that is above. And it looks like it is coming from the point C. Okay, two lines I am going to consider these two lines, and this line is this line looks like it is coming from the point C. We know the nature, it will pass through F. When it pass through F, those two lines won't be touched at any point, because those two lines are visible like both are traveling parallel. Okay, so these two parallel lines won't meet at any point. So we can conclude here the image is highly enlarged. Image is highly enlarged. Image size is highly enlarged. So we can't draw the image when you place the object at F. Okay, next. If I place the object between P and F, between P and F, I will draw here because we are going to get the image in that another direction. So I am going to draw the image object and lens here. Here is image object. One is incidenting at the P and another one is above. Another one is above that one. I am consider these two. Here I have considered parallel and above the line. Here I am going to consider at P and one is above line. See, we know the condition. If any ray of light incidenting at P, it will reflect back by having the same angle of incident. So this is, it will reflect. And here this above line, we know that one, it looks like it is coming from the point C. Okay, it is coming from the point C. And when you extend this one, see these two lines are not parallel. Here these two lines are parallel, but here these two lines won't be parallel. So how it is possible? That is because you are placing the object between P and F. That's why you will get such a nature. And when you extend these two lines backward, those two lines will converge at one point. Okay. Those two lines are converged at one point. That's why you are getting the image here. Okay. Here I explained one more time. Concave mirror. You are replacing the object between P and F. This is the object, top and bottom of that one here. And I'm going to consider two rays, that is above that one. One is below, that is pass through the point P. When it pass through the point P, it will reflect back by having the same angle of incident. How much angle it takes to incident? The same angle will take for the reflection. One more line, that is here, one more ray, that always looks like it is coming from the point C. So it will incident and reflect back in the same direction. So when you extend those two lines backward, you will get those two lines are going to meet at one point. That point gives you the image. That is behind of that one. That is this image is not real, virtual and erect image. Other than you are always getting real and inverted images. Real and inverted images, but here only your final stage. When you place the object between P and F, then you will get virtual and erect image. Okay, this is the ray diagram of a concave. Now let's come to the convex mirror. Okay. See, in the convex mirror also, concept is the same. But for the P pole, this point is F and here C. If it is P, F is F will be here and here is a C. And here, when you place the object at the infinity distance, I am going to consider the two parallel lines. Okay, two parallel lines when it incident on a convex mirror. Okay, on a convex mirror, it will reflect back. How no? See, parallel lines always it will pass through the point F, but it is not refracting, but a refracted light. It looks like it is coming from the point F. Actually, incidenting light is this one, and this is a reflecting line. But how it is formed, how it is reflected in this way, that is because it is looks like it is coming from the point C. That's why here also same. When the incident parallelly, we know that one it will pass through the point P in concave mirror, but here it reflect back in this direction, incidenting and reflecting. That means it reflected ray, it looks like it is coming from the point F. So this is actually reflected ray through the convex mirror. And here, if I place the object at a finite distance, okay, at finite distance, not at infinity, at finite distance. Here I am going to consider two rays. One is parallel. Always, generally we are selecting one parallel. And one more at C, and for the another ray diagram at F. Now here I am going to consider one more line. that is pass through the point C. One is parallel and one more is pass through the point C. But actually visibility from this side, that is these two lines. One is parallel and another one is downward, but actually it is going to meet at point C. And we know the nature, when incident at the C, it will reflect back in the same direction. It will reflect back in the same direction, and parallel line, it will pass through the point F. That means the reflected ray, it looks like it is coming from the point F. So this is reflecting. Okay, this is reflecting. See, but here these two lines are going to meet at this point. So the image will form here. Image will be form behind of the mirror. Okay, behind of the mirror. Here. So that is not real, that is virtual and erect. Here also you are getting point size image, but here you are getting virtual and erect, not inverted. Behind the mirror you are going to get the image. I hope you understood how to draw by knowing the nature of light. Okay, and the questions may ask like by placing the object in different position, like at C, at F, between P and F, like that we can see the questions. Place the object in different position, draw the diagram for the concave and convex mirror. Otherwise the question means to solve the problems, calculations. The questions may regarding this concept comes for the calculation. In that also we should know where will be the image form. When you place the object left, okay, when you place the object left of that mirror, where will be the image form? Right or left? Those concepts also necessary. So friends, I hope you understood today's this concept. And if you like my channel, if you like my class, subscribe my channel and click the bell icon to get a notification of my videos. Thank you.